Good morning, student. Today, so I would like to go over some of the problem that you guys most likely will be doing for the Algebra 1 final. So this one is just a review for Algebra 1 final. Okay, so let's take a look at that. The first one is all about the operation. So it's all about PEMDAS, all those things. So let's say that we're doing number 4 here, the one that looks kind of a little bit complicated. So let's say that we have integer, fractions, negative sign change, things like that. So anytime they see negative, negative, always convert that to its positive. So this one could be written as 9 plus 24 over 8, and then plus 5. Okay, so always if you see that two negative sign that appears at the same time simultaneously, so that means you want to change that to its positive. So 9 plus 5, that's 14, and then 24 over 8, 24 divided by 8, which is what, 3? So 14 plus 3, 17. Okay, so for this study packet here, so I just want to go over some of the complicated problem. So in case that you guys are going to be dealing that on the final. So absolute value of negative 5, so for number 6 right here, times the quantity of n over 3 minus p. So use the value of n equals negative 9, p equals 2. So basically what we have to do, we want to plug in a number for n and p. So n, which is negative 9, divided by 3, and then p, which is 2, minus 2. So started off with the parentheses, so negative 9 over 3, which is negative 3, minus 2, negative 5. And this one right here, absolute value of negative 5, which is 5. 5 times negative 5, and which is negative 25. And then for number 8, proportionality. So this one is about the comparisons of the fraction. So anytime they see things like this with the variable either on the top or down the bottom or both, so what we can do, cross multiply. So this one turns out to be 11 times b plus 1, the quantity of b plus 1. So that equals 6 times the quantity of b minus 1. And then what you can do here, expand it. Okay. So this one, 11b plus 11. So that equals 6 times b, 6b minus 6. And then collect the like terms. So subtract 6b on both sides. So we got 5b. And then subtract 11 both sides. So we do have negative 17. So that means b equals negative 17 over 5. So the other one is find each percent change. So state if it's increase or decrease. So from 99 to 35, so obviously this one is decreasing. So 99 minus 35. So the original amount, subtract the new amount, divide by the original amount. And then you want to convert this number to percentage. So 99 minus 35, so that will give you 64 over 99. So this one, reduce. If that's possible, if that's not possible, so just put into the calculator and then convert that to percentage. So it looks like this one is about like 63 point something percent. So divide it and then convert that to percent. And then for things like this, so what is 42% of 66? So anytime they see problem like 42%, so this one is like a part over the whole. So that's always the percent. So right now we do have the percent, which is 42% of 66, which is the whole. So let's say that x over 66, so that equals 42%. And then the rest of this, we can either cross multiply or just reduce the number first. So x over 60, so that equals, divided by 2 top and the bottom, so we do have 21 over 50. And then cross multiply, so 50x, so that equals 21 times 60. So 1 times 6, that's 6. 6 times 2, that's 12. So 1, 2, 6, bring the 0 over. And then divided by 50. So 1,260 divided by 50. So 2 times 50, that's 100. Subtract 26. Bring down to 0. So 4 times 5. Well, that's 2 is kind of small, so maybe 5 times. 5 times 50, 250. Subtract, so we got 10. Carry down a decimal. and then bring down to 0, so we do have 2, so 25.2. So solving for the equation, okay, so solving for the equation, let's do two problems right here. So let's do the one with the non-absolute value and the other one with the absolute value. So let's do 25. So anytime they see things that with parentheses, a lot of constant terms, the variable. So first thing that you were thinking about here, so distribute. So negative 6n, just bring it down. So negative 12 times negative 11. So that's going to be positive. So 12 times 11, not quite sure what that is. So just show all your work. So that will give you 132. So positive 132n, and then 12 times 8, which is 96, but it's negative because negative times positive, minus 96. On the right hand side, also you want to distribute. So negative 10n plus 40. And then at this moment, collect the like term or combine the like term first. 132n minus 6n, so that will give you 126n minus 96, so that equals negative 10n plus 40. And then add 10n on both sides. And then also at the same time, add 96. Combine them, so what we got here is 136n, so that equals 136, and then divided by 136 both sides, so we got n equals 1. And also you can always check the work by plugging the number back to the original equation. At both sides you come up with the exact same constant, so that means the solution is correct. Okay, so now what about the absolute value? So a lot of people are still kind of confused about the absolute value. So for the absolute value equation, so let's say that if you have absolute value of the quantity equals to a negative number, so that means there's no solution. The reason why that is because absolute value always makes things positive or 0. Okay, if the absolute value only equal to 0, so that means there's only one solution. But the things that if the absolute value equals a positive number, so that means it could be two solutions. It could be positive, negative, or both of them are negative, or both of them are positive. Okay, so now let's find out. Okay, so 31. So what happens if there's a number right in front of the absolute value? So we need to get rid of the number first. So divided by negative 6. So absolute value of 3 minus 9x, so then that would be 3. Because negative 18 divided by negative 6. And then once we end up with the form, like this kind of situation, so we want to break it apart. Negative, positive. So for the positive, we just leave that with 3 minus 9x equals 3. For the negative, we want to keep that as 3 minus 9x equals negative 3. And then for the rest of this, we just want to solve for x. So for the negative, solve for x. So 3 minus 9x equals negative 3. Subtract 3 both sides, so we got negative 6. Divided by negative 9. So we got x equals divided by 3 top and the bottom here, reduce, so we do have 2 over 3. Okay, so that would be the positive solution. What about for this one right here? 3 minus 9x equals 3. So subtract 3 both sides, so we do have negative 9x equals 0. And then divided by negative 9, so x equals 0. So two solutions. And now what about for the radical equation? Okay, so let's do one problem here. So radical equation, again, we want to isolate that the radical, just like the way that we try to isolate the absolute value. So like this one right here, negative n. So what we can do first, so you want to add n both sides. So we got radicals of 2n plus 34, so that equals 5 plus n. And then from here, you want to square both sides. So once we square both sides, so we do have 2n plus 34, so that equals 25. If you try to FOIL this out, so 5 squared, 25, 5 times n times 2, 10n. It's a binomial expansion, or using that the FOIL method, 5 plus n times 5 plus n squared. And then we do know that it's a quadratic equation, so that means we want to bring everything together to one side. So subtract 2n, subtract 34, both sides. Subtract 2n, subtract 34, So what we found here, we started off with n squared, 10n minus 2n, which is an. And then 25 minus 34, so then that would be negative 9. And then the rest of this, we want to factor it, so using the smiley face technique. So n times n, negative 9, so this one negative, well, the number here is positive, so 9 got to be positive, and then negative 1 got to be negative. So 9 times n minus 1n, which is an. So the left-hand side of the factor tree, whatever that you stay on the left-hand side under the i's right here, so we got n plus 9, group them together, n minus 1, the right-hand side of the factor tree. And then set equal to 0, so that means n equals negative 9, and then n equals 1. Okay, so again, you want to plug in a number back to the original equation and check the work. So n times negative 9, negative 18 plus 34, which is 16. Square root of 16, that's 4. And then negative 9, so positive 9. Okay, so but 9 plus 4 right here, so it cannot be 5. So I got to be careful, one of the solution got to be extraneous. So again, plug in negative 9, so we got negative 18 plus 34, 16. For square root of 16, that's 4. So 9 plus 4, that's 13, it's not 5. So this one would be the extraneous solution. So plug in 1 here, so n times 1, so that's 2. 2 times 1, that's 2. So 2 plus 34, 36, square root of 36, that's 6. And then negative 1, subtract 1, so it's 5. So this one would be the valid solution. Exponent, so make sure that you guys using the properties of exponent. Okay, so anytime that whatever the basis that you have, the whole quantity to the power of 0, it's always 1. But what about something like this? So there's a power outside, or the exponent, distribute, so negative 2 quantity square. U to the power of negative 2 to the power of 2, multiply the exponent, u to the power of negative 4, v squared, quantity square, so v to the power of 4, times negative 2, v to the power of negative 5. So negative 2 quantity square, so we got 4. So u, nothing's related, so just bring it down first. So v to the power of 4 times v to the power of negative 5, so then that'd be v to the power of negative 1. Multiplication, same base, we combine the exponent. So 4 plus negative 5, negative 1. And then don't forget about that negative 2, we're going to multiply that with 4 as well. So 4 times negative 2, negative 8. And anytime that you see the negative exponent, so whatever that you have for the basis there, we just want to bring those things down to the denominator. So u to the power of 4, v to the power of 1. Okay, so this one is called the reciprocal form with a negative exponent. Simple form, just leave it like that. And now let's do the one with the quotient. So like this one here, negative. So negative 1 to the power of 3. And then the rest of the power here distribute. So we got v to the power of 3, u to the power of 9. You know, normally people like to do it that way. But another way that you can do it, start it off with the parentheses. Whatever that you have, you can always simplify it first. Okay? So one thing that we notice, so this one is negative with the other negative. So negative times negative, so that turns out to be positive. So it depends on which way that you prefer. You know, one way it's easier than the other. So negative, negative, it cancels out, so it's positive. And then for the denominator, so whatever the base, common base that we have, so let's just multiply those terms first, not the term, the elements. So 2 times 1, so then that's just 2. So u to the power of 4 times u to the power of 4, u to the power of 8. V to the power of negative 3, v to the power of negative 4, so v to the power of negative 7. Everything else that we have in the numerator, bring it down. And now the rest of this, so you just want to simplify it a little bit more. Quotient, so v to the first power divided by v to the power of negative 7, so v to the power of 8. U to the power of 3 divided by u to the power of 8, then that'll be u to the power of 5, stays in the denominator. The 2, just leave that in the denominator. And then the rest of this, so what we found, it's all the whole quantity to the power of 3. And then power, distribute, top and the bottom, v to the power of 8 to the power of 3, v to the power of 24. 2 to the power of 3, 8. 2 times 2 times 2. So u to the power of 5 to the power of 3, u to the power of 15. So then that would be the final form. So again, it's all about using the properties of exponent. Okay, so now what about this? Name the polynomial by degree and number of terms. So 2 terms, binomial. What's the highest degree? 4 degree. So this one is the 4th degree binomial. You know, people saying that it's 4 degrees, so it's what? It's a quintic. Or no, it's a quartic. It's a quartic binomial. So that's another name for it. Like this one here, first power. So that means it's a 1st degree binomial. Okay, so 1st degree binomial. Or people saying that it's a linear binomial, that's another name for that. 1st degree binomial. Or it's called a linear binomial. Okay, so now let's do the one that we have to combine the like terms. So any time that you want to combine the like terms, so that means you want to find out the same variable with the same power. So whatever the coefficient that they have, so you either want to add or subtract. So started off with this one, 13xy. So anything that's related with xy, so we do have this one, negative, negative, so positive. So the best thing that you want to do, so started with the distribution with the parentheses, you know, especially the negative sign right in front of the parentheses. So without the negative sign, if that's just positive or plus, just rewrite those sign with the terms. So negative, negative, positive, negative, negative, distribute, positive. So now what we found here, 13xy, 4xy, so then that would be considered 17xy. So make sure that you check the rest of the xy term. So only those two. So 17xy. And then the next one, negative 6y squared. Anything that's related with y squared. Negative 3y squared. 9y squared. So this one doesn't count because this one, that comes along with x squared as well. So negative 6 minus 3, negative 9. Negative 9 plus 9, 0. So the y squared term got canceled. And then what's left here, we got 14x to the power of 4. Nothing's related with 14x to the power of 4. So just carry that over. And then also this one, nothing's related. So just carry that terms over. X squared, y squared. And normally people like to put in this one from the greatest power to the least. You can certainly do that. So 14x to the power of 4 plus x squared, y squared. And then plus 17xy. And also people might be wondering, can we factor this? Yes, certainly we can do that. Take out the greatest common factor. But normally, if that's simplifying, you want to put it into standard form. Standard form, that means it's from the greatest power to the least without factoring. And now what about the one that you need to find the product, FOIL? So let's do the one that with binomial multiplied by the binomial, like 59. So negative 5p times 7p, so the first term. So negative 5 times 7, negative 35, p times p, p squared. And then outside, negative 5p times negative 5, positive 25p. 8 times 7p, so 56p. And then 8 times negative 5, negative 40. So what we got here is negative 35p squared. 25p plus 56p, which is 81p. And then minus 40. Again, the standard form from the greatest power to the least. So now let's do the one with the binomial multiplied by the trinomial. So negative x times 6x squared. So normally what I would like to do, so let's just regroup them. So negative x times the trinomial, the quadratic trinomial, because that the highest power is 2. And then minus 3 times the exact same quadratic trinomial. So let's put it this way, it's easier to multiply those numbers with the terms. So negative x times 6x squared, so then that'll be negative 6x to the power of 3. Negative x times ax, so negative ax squared. Negative x times 8, negative ax. And then over here, negative 3 times 6x squared minus 18x squared. Negative 3 times ax, negative 24x. And then negative 3 times 8, negative 24. And then again, from the greatest power to the least. So negative 6x cubed. So negative ax squared, let's find a common term here. Negative ax squared, negative 18x squared. Combine them, so negative 26x squared. And then negative ax, negative 24x, which is negative 32x. And then constant, just bring it down, minus 24. So from the greatest power to the least. So it's a quadnomial. It's a cubic quadnomial. Okay, so now let's see what else that we have for this. Again, if that's a power like this, you can always put it this way, a minus 6x times the quantity, a minus 6x. Or you can apply the formula, a minus b quantity squared, which is a squared minus 2ab plus b squared. Okay, so now let's do the one with the normal division. So let's say that we do have a trinomial divided by the monomial. This one can be always written this way. Okay, so the numerator, which is the dividend, and then divisor, which is the monomial. And then what we can do, we can always separate it. So 18b cubed over 6b. So instead of using the long division format, we can always separate those terms. So 2b squared over 6b plus 3b over 6b. And then once you end up with the fraction, so what we can do, reduce. So 18 over 6, 3. B to the power of 3 over b, b squared. 2 over 6, 1/3. B squared over b, just b. 3 over 6, 1/2. Reduced by 3. And then b and b got canceled. So here's the final form. And then for the trinomial, so normally your teacher would be asking about this like factoring. So again, the best way to do the factoring would be using the cross method or the smiley face. So like this one right here, there's no greatest common factor, so we can just break down the first and the last number. So 15v squared, so this one could be 5v, 3v. So basically just like the factor tree or the prime factor tree. 96, so this one, it's a critical number, so kind of big. So let's just put it into, so we do know that's an even number, so most likely it's divisible by 4. Or maybe by 8. Okay, so let's find out. 96 divided by 8. Okay, so 16 remainder, so we got 12. So 12 times 8, that's 96. So let's put in 8 times 12 right here. So 3v times 8, that would be 24v. And then 5v times 12, then that would be 60v. If that's the case, you only end up with what? 84v, but we need to end up with what? 132v. So another way that we can deal with this, we can swap the number, or maybe we can use the other kind of combination. So this one, besides being 8 times 12, so this one can be also written as 4 times 24. Okay, so let's try 4 times 24, because that's the number in the middle. The sum of the product is kind of big. So let's use 4 and 24. Okay, so 3v times 4, then that'll be 12v. 5 times 24, so 5 times 4, that's 20. 5 times 2, 10. Plus 2, so it's 120. So 120v, and then once you combine them, that's exactly 132v. Okay, so again, the product of the sum of the product got to be the same as the coefficient in the second term. So what we found here, so we got 5v plus 4. Again, the left hand sides of the factor tree, so you want to group those elements together. And same thing happened with the elements on the right hand sides of the factor tree. So 3v plus 24, just group them together. And now you may notice that 3, 24, so things that they share in common, so we can take out 3. So 5v plus 4, and then 3, pull out that 3, so we got v plus what? 8. Another way you can do it, you can take out the greatest common factor first, as one I mentioned before. So 15, 132, 96. So all those numbers, so they're all considered the multiples of 3. So we can pull that out first, and then to factor it. So once you pull it out, so we just reduce down the coefficients. 5v squared plus 132 divided by 3, which is 44. and then 96 divided by 3, which is 32. So try to do it this way, eventually you end up with the same thing. So 5v plus 4, and then v plus 8. So using the smiley face method, so 5v, 1v, and then over here, which is what? 4 and 8. So 5 times 4, 20. So 1 times 8, 12. It's actually the other way. So it's 5v times v, and then this will be 8 times 4. Okay, so making sure that this one, okay, in the product, out of product, yep, so eventually it's going to be the exact same thing. Okay, so now let's see what else that we have for the rest of this. So let's try another one. So let's say 78. So this one is 9x squared. So 9x squared, break it apart. Again, there's no common factor here. 9, 24, 16. So 3x, 3x. So 16, let's put it 4 and 4. So 3x times 4, which is 12x. 3x times 4 again, 12x. So the total is 24x. So this one can be written as 3x plus 4 times the quantity of 3x plus 4. And also could be written as 3x plus 4 quantity squared. Okay, so solving for the quadratic equations, so things like this, anything that's being factored, so you just need to set the factor equal to 0, set the factor equal to 0, and then solve for x. So for this one, x equals negative 1 over 3, subtract 1 divided by 3. This one, subtract 4 both sides, so we got negative 4. And then what happened to the one that is the one has not been factored, like this one? So take out 3 first. So we got x squared plus 4x plus 3 equals 0. And then the rest of this, you want to factor it. You can do it mentally. You can use the smiley face method. So x plus 3, x plus 1. So that means x equals negative 3, and then x equals negative 1. Because the factor equal to 0. And what about if that's like a non-standard form? So bring everything together to one side and then factor it. So x plus 8 and then x minus 1. So x equals negative 8 and then x equals 1. So solve each equation by using the quadratic formula. Okay, so using the quadratic formula. So quadratic formula, it's x equals negative b plus minus square root of b squared minus 4ac all over 2a. So before you do that, you need to bring everything together to one side and then apply the quadratic formula. So like number 90, so this one is 4m squared plus 4m minus 2. Bring everything together by adding 4m both sides and then subtract 2 on both sides. So this one, you can reduce that a little bit. You can divide it by 2 both sides. So 2m squared plus 2m and then minus 1 equals 0. So if you divide it by 2 both sides here, you can just reduce down the coefficient. So that means a is 2, b is 2, and then c it's negative 1. And then you plug in a number, solve for x. So write an inequality for each graph. So if you see anything like that going to the right, that means it's what? Greater than. Closed circle, that means it's equal to. Like this one, x is greater than or equal to negative 1. Like this one here, x is less than or equal to negative 2. So solving for the inequality, so got to be very careful. If that's a negative variable, so you want to divide it by negative 1. So divide it by negative 1 both sides. Inequality, once you divide it by negative, so you need to flip the sign. So greater than equal to turns out to be less than or equal to. 5 divided by negative 1, negative 5. So p, it's less than negative 5. So that means it's a closed circle, which is going to the left. Like that. And what about the way that you deal with the compound inequality? Let's do the one with the or and one with the and. So for the or, you just want to solve for the inequality separately. Like 2a minus 12 is greater than negative 20. Add 12 both sides. So we got 2a, it's greater than negative 8, because negative 20 plus 12, divided by 2. So we got a, it's greater than negative 4. So a is greater than negative 4, so that means it's going to be going this way. Open circle at negative 4. But don't forget about another inequality. So 5 minus 2a is greater than or equal to 29. So subtract 5 both sides, so we do have 24. And then divided by negative 2. Again, anytime you divide it by or multiply by a negative number for the inequality, so you want to switch the sign. So a is less than or equal to negative 12. So equal to, close circle, going to the left, like that. Okay, so the rest of this, they're quite similar, but let's do the one with the and. What about like number 100 right here? So in order to isolate that r, you want to subtract 3 on 3 sides, the left, the middle, and the right. So negative 1 minus 3, negative 4. It's less than r, and r is less than or equal to 1. So this one is being bounded in between negative 4 and 1. So, and then you want to connect those two solid points. So solving for the absolute value inequality. So again, anytime that you see the absolute value inequality, it's less than equal to 0 or negative number. So that means there's no solution. Okay, so then that'd be no solution. Well, because that absolute value cannot be negative number. Absolute value of the quantity is always either 0, equal to 0, or positive. If that's less than 0 or less than negative number, no, it cannot be. There's no solution being found right here. So it looks like they're just like a normal cases. So now let's do the one like 108. So again, absolute value, so you want to get rid of the number right after that or right in front of the absolute value symbol. So this one, subtract 3 both sides, so we do have 36. And then absolute value less than, equal to, break it apart, negative, positive. So for the positive, you just want to leave that with the original inequality without the absolute value symbol. So 6 minus 6x is less than or equal to 36. Subtract 6 both sides, so we do have negative 6x is less than or equal to 30. Divided by negative 6. Inequality, flip the sign, so x is greater than or equal to negative 5. And then for the negative, so 6 minus 6x. So this time, you need to flip the sign, greater than or equal to, and also you want to convert the number, the constant, to its negative. Subtract 6 both sides, so we do have negative 6x is greater than or equal to negative 42. And then divided by negative 6. So x, it's less than or equal to 7. So one is greater than or equal to negative 5. Going this way. The other one is less than or equal to 7. Going back to the left. So eventually they're going to be intersecting. Because one is coming to the left and the other one is coming to the right. Okay, so this one, if you see that less than or equal to with the inequality absolute value, so that means it's always considered and. Okay, less than, and, and. So that means always the union is always connected. If that's greater than, like number 107, so greater than, that means it's going to be or. Because the ER, that means kind of like similar to or. Okay, or that means it's going to be two separated directions. So that's the best way to recognize the structure for the absolute value inequality. Less than or equal to and intersect. Greater than or equal to or two separated directions. Okay, so finally we're getting to the radical. So the way to simplify the radical is about making the factor trees the perfect square number, non-perfect square number. So let's do the one that it's a little bit more complicated. Okay, so like 117, excuse me. So 112, if you think about that, the number is divisible by 2 because that's even. So divided by 2, so we do have, okay, root 2. 11 divided by 2, well, this one, 112 divided by 2, so we got 56. And think about that 56 even number again, so this one is divisible by 2, or perhaps divisible by 4. So 4 and, okay, so let's see. So 1 times 4, that's 4, 16, so 14. Okay, so if you just rewrite it, so it's 2, 4, 14. Another way to rewrite this one, so this one would be considered 4, 16 times 7. Okay, so 16 times 7, so 4 times root 16 times 7. So we just want to end up with one perfect square number. The other one is a non-perfect square number. 128, so think about that. Is that number divisible by 4? Yes. So which is what? 32. 4 and 32. But don't forget about that 32. It's like what? It's like 16 times 2. Or this one can be written as 64 times 2. Again, think about the perfect square number. 64. What's square root of 64? 8. 2 root 7, nothing we can do. Leave it. Minus 2 root 32. So minus 2 root 16 times 2. Okay, so I just want to get more space here. So let me get rid of that factor form right here. So now one thing at a time. So root 16, that's 4. 4 times 4, 16. So 16 root 7 minus root 64, 8. 8 times 2, 16 times root 2. Minus 2 root 7 minus 2 times root 16, that's 4. 4 times 2, 8, 8 root 2. As you can see that the one with the same radical, root 2, root 2, root 2, we combine all those coefficients. So negative 16 minus 2, negative 18, minus 18, negative 26. So we got 16 root 7 minus 26 root 2. Okay? Equal sign. So now what about the one that you need to multiply? So anytime that you need to multiply the radical, so that means you want to multiply those radicands together. So this one is written as 5 times 1, which is 5. Root 15 times root 10, square root of 150. 5 times 1 root 3, so 5 times 1. If the number is not shown right in front of the radical, it's always 1. So it's 5, and then root 3, just leave it like that. And then 150, you can always break it apart if that's factorable. So it looks like it's non-factorable. It's not going to be the perfect square number. It's like 15 and 10. So none of those numbers is considered perfect square root. Okay, so just keep it that way. Okay, so now let's do the one with the variable. So like this one, simply FOIL 6 times root 7x times 6 root 7. So this one 6 times 6, 36. Root 7 times root 7, so that would be 7. Root x is still there, so root x. 6 root 7 times 3 root 6x. So this one, that would be considered 3 times 6, which is 18. Root 7 times root 6, root 42. And then x squared. Okay, so just keep it that way first. And then inner product. First outside, inside. So negative 2 root 6 times 6 root 7. So negative 2 times 6, negative 12. Root 6 times root 7, root 42. And then finally, the last term. Negative 2 times 3, negative 6. And then root 6 times root 6x, root 36x. And then try to simplify this a little bit. So 36 times 7, 6 times 7, 42, 3 times 7, 21, plus 4, 252, root x. And then over here, 18, root 42, root 42, anything that we can simplify, nothing we can do with that, so leave it as the way it is. But x squared, that's just square root of x squared, that's x. 18x, root 42. Minus, this one is just 12 root 42. And then over here, root 36, 6 times 6, 36, root x. And looks like we can group this together, the last two terms, the first and the last term together. So 252 minus 36, 12 minus 6, 6. 4 minus 3, 1, so 216 root x, and then 18x. Okay, so let me just check one thing here real quick. Yeah, nothing we can combine, just carry that over. So plus 18x root 42 minus 12 root 42. Okay, so this one is a little bit complicated because a lot of those radicals number right in front of the radical that you need to multiply. And now let's do the one with rationalizing. If you see anything like this one, well, this one is a perfect square number. But let's do the one with the non-perfects, like 2 root 3 over root 27. So you probably notice that the radical, we can divide it or reduce it. So this one is 2 over root 9. So this one basically just consider like 2 over 3. Because 3 over 27 under the same radical, reduce. So 2/3. But now let's do the one that requires rationalizing, like this one. So you multiply by the conjugate. So 4 minus 2 root 2, top and the bottom. Conjugate, it's like a plus b, or a plus root b. So the conjugate, then that'll be a minus root b. So 4 times 4, 16. 4 times negative 2 root 2, negative a root 2, all over. So this one is just the difference of 2 squared. 4 times 4, 16. 2 root 2 times 2 root 2, which is 4 times 2, which is what? 8. So minus 8. So we got 16 minus a root 2 over 8. And then reduce. Binomial over the monomial, so 2 minus root 2. Okay, so the radicals, things that you want to simplify. So 576 square root, again, try to break down the number. So this one, so find out that if that's divisible by 4. So 1 times 4, that's 4, 17. So 4 times 4, 16. 16 again, so 144. So this one is considered root 144 times 4. And then what about the variable? The variable can always rewrite it with the rational exponent. So it's like m to the power of 5 over 2. Because that the square root is like, 2 outside with the index number. And then p to the power of 3 over 2, and then q, which is what, 1/2. So this one, just want to simplify that root 144, which is 12, and then root 4, that's 2. So 12 times 2, which is 24. So root 576 is a perfect square number, which is 24. But it's negative. And then what about this? This one, convert that to the mixed number. So this one is like 2 and 1/2, right? 2 and 1/2. And then this one is 1.5. And then this one, nothing we can do, just leave it as 1/2. As you may notice that 2, 1. So those are considered the perfect power, which stays outside, m squared. P, just stay outside. And then what about the fractions? The fraction here, we just want to keep those variable under the radical. So it's like a rational exponent form back to the radical form. So m, p, and q, just like that. And then find out the slope of each line. So slope-intercept form, mx plus b. So the slope is 5, 4. Y-intercept would be 5 then, but no need to say that. This one, count it, rise over run, just pick 2 points, but pick the perfect integers. So 0, 0 to this position, which is what, 1, 3, 1. So rise over run. So rise is up 1, 3 unit to the right. So the slope here would be 1/3. Going down, so that means the slope is going to be negative. Again, pick 2 point, count it, rise over run. So find the slope of the line parallel to each given line right here. Okay, so this one, convert that to the slope-intercept form. Subtract 1 both sides, divided by -1 both sides. So we got y equals -4x plus 1. So the slope is -4. So 2 lines are parallel, that means the slope got to be exactly the same. Find the slope using the slope formula, which is y2 minus y1 over x2 minus x1. So label it, the first point, x1, y1, x2, y2, and then 20 minus -18, or 20 plus 18. Well, let's just show all your work. And then x2 minus x1, -12 minus 4. So this one, combine them, so which is 38. Combine them, so -16, divide it. So it looks like this one, it's not divisible. If this one is not divisible, so that means just reduce it. So this one by 2. So we got 19 over -4. Over -8, excuse me. Divided by 2. Rise over run. And then sketch the graph. So y equals 4x minus 2, that one's pretty straightforward. Let's do the one that's a little bit more hectic. So this one right here, isolate y by itself. So at ax, at 15 both sides, so we got ax plus 15 equals 3y, divided by 3 both sides. So we got a third x plus 5, so that equals y. So the slope is a third, and then the y-intercept, which is 5. So started off with the y-intercept and then count it, rise over run. So you might be wondering, goes up by 3, we're kind of running out of space here. But another way you can do it, can convert the rise over run to its negative over negative. So down 8, 5 minus 8, then that'll be negative 3. And then 3 unit to the left. So 1, 2, 3 over here. Again, down a unit and then 3 unit to the left. So for the initial point, the y-intercept, and the final position right here, basically just connect them. Not the final position, but it's the second point. Okay, so connect them. So just a straight line going that way. As you can see that the slope is positive, that means the line is actually increasing. Okay, so the rest of this, they're quite similar. Make sure that you know how to convert it back to the slope-intercept form. And write the slope-intercept form for the equations. So this one, like 146. So 7y, so that equals subtract 3x both sides. So we got negative 3x minus 28 divided by 7 for each term. So y equals negative 3 over 7 times x minus 4. Okay, so the slope-intercept form. This one, try to get the slope first, while the y-intercept is actually given is 0, 3, and then this one is 3, 0, so that means the slope here, so it looks like it's going to be negative 1. So 3 minus 0, 0 minus 3, negative, so negative 1. So using the slope-intercept form, negative 1x plus 3. Okay, so the rest of that is quite similar. And now, what about this one? Write the slope-intercept form of the equation of each line given, and the slope and the y-intercept. Yeah, just like what we did. So y equals negative 1/3 x plus 5. Also writing the equation in the slope-intercept form, so through the point with the slope. So this one using the point-slope form. So the point-slope form is just kind of under the same structure of the slope formula. So let's say that we do have the slope. M equals y2 minus y1 over x2 minus x1. So think about that. If you try to cross multiply, you end up with y2 minus y1 equals m times the quantity of x2 minus x1. Compare and contrast. Without labeling that x2, y2, just name them normally, x and y. It's the same as the point-slope form. So using the point-slope form, we got y minus y1, which is 1. Okay? And then, so that equals 4/3 times x minus x1 minus 3. And then the rest of that distribute. So 4/3 times x, 4/3 x. 4/3 times negative 3 minus 4. Add 1 both sides. So add 1 here. So we got y equals 4/3 x minus 3. Okay, so 2 points are given, so that means you want to find the slope first. Once you get the slope, and then you can use that x1, y1, the point-slope form, to get the equation of a line. So this one is quite similar to the previous one. Again, if two lines are parallel, that means we're using the same slope. And then using the point-slope form, so y minus 5, so that equals negative 7 over 4, so times x minus negative 4. Again, this one is just a setup. The rest of that, simplified it all the way through. Graphing inequality. Okay, so this one, so you want to find out the shaded area. So 3 unit down, and then negative 1/3, 1 unit down, 3 unit to the right. Okay, connect those dots, because that is negative 1/3. So 1 unit down, 3 unit to the right. So less than or equal to, so that means it's going to be a solid line, because that there's an equal sign involved. Okay, so this one's, oops. So it's going to be a solid straight line. Another thing is that you want to find out the area where you want to shade it. So the area that you want to shade it, then that'll be less than, equals less than, so that means down below the line. And also put in the arrow, goes all the way to continuously. So the other one is quite similar. So this one is the system equation. You want to find out the point where they intersect. So y equals negative x plus 1, so up 1, negative 1 over 1 for the slope, negative 1. So 1 down, 1 unit to the right. Okay, 1 down, 1 unit to the right, or 1 up, 1 unit to the left. Okay, get the equation of the line and then sketch the graph. That's what we have. And then the other one, negative 2 down 2 units. Negative 1, 4, 1 unit down, 4 unit to the right. Okay, 4 unit to the right, then that'll be over here. So eventually, this line is going to be going this way. And then the point where they intersect, then that'll be this one. So it's 5, comma, negative 3. You can always plug in the number back to the original equation and check your work. Okay, so it looks like it's 5, comma, negative 3. Well, wait, it's actually 4, comma, negative 3. Okay, so maybe the graph that I did here, okay, this one, the line gotta be precise, okay? So the first line that I drew, so that point, okay, so this one is dotted all the way through. Okay, so connect it all the way down. And then the other one, connect them. So the point where they intersect is supposed to be 4, comma, negative 3. So again, the graph got to be very precise. So using substitution, so anytime that you want to apply substitution, that means you want to solve for one variable in terms of the other, and then you plug in the expression to the equation, to the another equation. Like this one right here, the first and the second equation. So the first equation, what I can do, isolate that x by itself, so that means negative 5y plus 20. Subtract 5y both sides, and then back to the second equation. So instead of using x, we're using negative 5y plus 20 minus 5y, so that equals negative 20. Distribute, so 15y, negative 3 times 20, negative 60 minus 5y, so equals negative 20. So 15y minus 5y, then that'll be 10y. And then negative 20 plus 60, then that'll be 40. So y equals 4. So once you solve for y, you can solve for x. So negative 5 times 4 plus 20, so negative 20 plus 20, so x would be 0. Also, you can check your work by plugging the number back to the original equation. 5 times 4, 20, x equals 0, so 20 equals 20. Negative 3 times 0, nothing. Negative 5 times 4, negative 20. Elimination. Elimination, that means you want to multiply, you want to come up with the exact same coefficient with the variable. So like this one, multiply by negative 5 for the second equation. So we got 5x plus y equals negative 13. So that's just rewriting the first equation. Second equation right here, so that turns out to be negative 5x minus 10y. So that equals negative 5. Combine them, so 5x plus negative 5x, 0. Cancel them out. 1y plus negative 10y, then that'll be negative 9y. Negative 13 plus negative 5, then that'll be negative 18. So y equals 2. So once you solve for y, plug in the equation back to the second equation. Solve for x. So 2 times 2, 4, 1. And then x equals 1 minus 4, negative 3. So it's negative 3, comma 2. Okay, so solving for the system inequality, the linear system inequality, again, just make the graph and find out the area where you want to shade it. So similar to the problem that we were talking about before, but instead of doing one line, it's 2 lines. And like this type of problem, just by plugging the number and then PEMDAS, it's pretty straightforward. This one too, plugging the number back to the equation and then evaluate, okay? So sometimes, teacher probably don't ask things like that for the final. And then the rest of this, find exclude the value, so basically just factor it and then reduce. Like this one, if you try to factor it normally, So this one, let's see, r squared minus 5r minus 36. So 9 times 4, so r minus 9, and then r plus 4 over r minus 9. So the simplest form would be considered r plus 4. Exclude the value, that means r cannot be 9, or r equals 9. Because when r equals 9, the whole thing would be undefined. Okay, so the rest of this is quite similar. So find excluded value by reducing, factoring. Okay, so thank you for watching the video today. So I'll see you guys next time. Take care.